All right, so one of the properties of gases that we're going to be talking about are the gas's pressure. Pressure is equal to a force over an area. So if you have a bigger force, you have a bigger pressure, or if you have a smaller area, you also have a bigger pressure. And so remember, with our model of the gases, the pressure of a gas comes from it colliding with the containers of the wall, or the walls of the container. And if we think about what that means kind of on everyday life, right? We are surrounded by gases, surrounded by air, and our Earth kind of keeps our atmosphere together, which is filled with all kinds of gases. And so these gas molecules are actually pushing down on you. And so you're constantly under what's known as atmospheric pressure, which is about 14.7 psi. So yeah, that's pretty cool. And then, right, we've probably experienced this, right, when we go up to high elevations, maybe get on a plane or whatever, you're just driving up a big mountain, your ears pop, right? So that's because down here at the, base level, you have a relatively high pressure because you've got a lot of gas pushing down on you. And then when you get higher and higher up into the mountains, you have less and less of this column of air pushing down on you. And so there's less pressure. Right, which is what makes your ears pop. It's also harder to breathe up in higher elevations, and that's because there's less gas up there, so less oxygen for you to breathe. Anyways, we can measure pressure with a number of units. The SI unit of pressure is the Pascal. 1 Pascal is equal to 1 Newton per meter squared. A Newton is a unit of force, and then meter squared is, a unit of area, so force per area. So it makes sense. Of course, we've got the kilopascal, which is just equal to 1,000 pascals. And even though the Pascal is the SI unit for pressure, it's not going to be the one that we most commonly use in this class. And neither is this one, but just here's kind of maybe more relevant one, right, for your car tires. Pounds per square inch. Right, that's your PSI. That's probably the one that you kind of encounter on the most on your daily basis type of thing. Just to give you a little idea, the air pressure at the sea level is about 14.7 psi. The main unit we're going to use in this course is atmospheres. Gets the symbol ATM. And at sea level, the atmospheric pressure is 1 atmosphere, right? Which makes sense. That's why it gets the name atmospheres, right? How many atmospheres are pushing down on you? Other units include the bar or the millibar. This is what's used most commonly in meteorology. So if you're like a weatherman or something. Inches of mercury or millimeters of mercury are also relatively common, and I'll show you a picture of a barometer where that comes from here. 1 millimeter of mercury is equal to 1 torr, which is another common unit. And then 760 torr is equal to 1 atmosphere. So I want you to go ahead and memorize these units, but then the rest of them, if I want you to do a conversion, I'll give you the units, right? So let's go ahead and memorize those. And we're mostly going to be using atmospheres and torrs, maybe a little bit millimeters of mercury here and there. Where does millimeters of mercury come from? That comes from how they originally measured pressure with a barometer. And so you've got, a pool full of mercury with this tube right here, where there's a vacuum in the top. And then the atmosphere is pushing down on this tube, which is causing the mercury to rise. And the greater the pressure, the higher the mercury goes, and then you measure the height of the mercury, and then that's equivalent to your pressure, right? You can see at 1 atmosphere, it's equal to about 760 millimeters, which is 760 torr, which is 1 atmosphere.